So welcome back. I hope you enjoyed the coffee and the cookies and everything, and have now ready to ask our not one, not two, but three Nobel laureates here today. Questions you might have, and not only three Nobel laureates, but Nobel laureates over 2 Nobel years. This is sort of a unique chance for the audience to, fire off your questions about how, questions you have about what you should do to be sitting here next time. So without further ado, I will, please raise your hand if you have a question. I see a question over there. Yes.
Can you hear me?
I think so. If you speak loud, yeah.
I have sort of a general question for all three of you. First, thank you, of course, for telling us about your story and your journey. What I was wondering if do you have in each of your respective field any science question that you think is particularly interesting, or that you would like to answer or see answered?
Can you repeat the question?
Yes, so the question is, in your 3 fields, what do you perceive as urgent questions that you would like to see answers to? I think is that the question?
Yeah. No.
No.
Absolutely. Absolutely. I mean, there's so much more to be done. In my own field, I'm particularly interested in understanding how gravity works around a supermassive black hole and that role that black holes play in the formation and evolution of galaxies. But that's just one of many, many questions that I'm personally interested in. And I'm going to hand the mic this way.
Yeah, no, I think it's clear that astrophysical research in its generality is in a really golden age right now. And that is because of technology. I think we've made that clear. Will it continue to do so? That's a harder question. Why? Well, because what we do costs a lot of money and time. The time we have, right? But the money, And in the United States, for instance, very clear that during the Sputnik era, a lot of money went into research and also then into basic research. But that doesn't have to be the case. It can happen that there are more important things all of a sudden which the population finds critical. So in a way, in astronomy, we must be extremely grateful that despite the fact that you would say, well, the stars are still there in the 3,000 years, why do we care to, can't you do something more important now? This curiosity element, which we are tickling, hopefully with you and others, is really the element where we can hope we can still continue.
Well, let's say that as far as I can think, one very big problem is to fully understand the difference between mean field approximation and things derived from mean field approximation to what happened to reality. I mean, we see that mean field approximation gives a lot of this fine description of the reality. There are some discrepancies I wrote the corrections, and one problem that will be very interesting to understand these kind of things. On the other hand, I don't think that this is the correct answer. I think the correct answer to your question is some problem that we, for the moment, we have not really formulated and can be solved. But which is this problem, I don't know.
Thank you. More questions? There you go, David.
So I have a question more about the sociology of doing science. And I was rather impressed or surprised about the number of women I saw in these large teams of astrophysicists. And of course in physics, and I think we're very acutely aware of this in Sweden also, it's difficult to attract women into our field. I just had from the coffee break conversation with my only female PhD student about this. She was also surprised at this. And I wonder, could we get your perspectives on women in science? What could we do to make it more attractive for them to enter physics? And yeah,
I have some thoughts about this. I mean, one, I think the fact that you see a lot of women and a pretty diverse group that works with me reflects the fact that I'm diverse. So I don't think that's representative of the field. So I think that one of the key ways in which you move the needle on that is actually by diversifying the faculty, because that attracts the next generation. It's actually, somebody at lunch was asking me, why do I still teach at the undergrad level? And I've always taught at the undergrad level because I think it's so important that the youngest students see that there's a diverse group of scientists. I'm not an expert in diversity or how one attracts, but I can get up there and show them that there is somebody that looks like them, or is somebody that looks different than what has traditionally come before that. So, me personally, I think that being visible is a really important way in which you move the needle on that.
Well, when I started in backward Germany as director, initially in 1986, the number of female students and postdocs was 0.000. Exact. And now, at our institute, we are hovering near 40% and increasing. 2 weeks ago, I was in a smallish city in southern Bavaria called Augsburg, and there were 1,300 students congregating there to talk about space research in general terms. And there were several prizes given out. In total, about 6 prizes, I believe, to little teams, 5, 6 people. So a total of 30 prizes. Of these 30 prizes in MINT, so physics, mathematics, technology prizes given out there, I would say of the 30, about 22 went to female young students. So I'm very hopeful. I'm very hopeful. We have to work at it, but I'm very hopeful. Okay, I think we shall not go back.
Well, in Italy also at my time, there were very few students in physics. There are a lot of students and female students in mathematics. The situation was opposite, but most of these people that were doing mathematics were interested not in research, but in teaching mathematics at high school. And on the other hand, in these days, we have a lot of, we have more or less something not far from parity of sex or gender in a university, and I think also at the level of doctorate. What happens maybe also PhD, but after PhD, what happens that some it's much easier for women to leave a university, to leave from when at the age of 30. So there is a lot of people that leave university at that age because of constraint with the family, the difficulty to move in if you are married. The husband always decides where is supposed to. There are a lot of sociological problems. So I think that this is something that is going to change, but it takes time, and I think that one needs some kind of affirmative actions in order to change the situations of one kind or another.
I have to have the final word. As Giorgio was speaking, it occurred to me to raise one other issue, because as he mentioned that at age 30 women often leave the field, and that often has to do with having children. So I'm actually really delighted that my 2 kids are here in high school and university. And one of the things that I think UCLA did that was so smart in terms of helping women persist, not only persist, but excel, was having a very effective daycare within the university. And in fact, I think that daycare system, I often call it the secret weapon of the university, because it's used as a recruitment and retention tool. So not only does it provide wonderful care for your children, but it also connects a group of faculty who are trying to figure out how do you do this job and have children at the same time. And then those are connections that persist well after your children leave the university. So then you also create this university that has really interesting connections across the university that can help you be effective in leadership positions long after your children have moved on.
Thank you. Over there.
Thank you very much for your wonderful presentation. So I had a question, like as you progress in your research career, so you deal with a lot of new things, like many new questions to tackle. Also your collaboration grows. So how do you manage your time to really stay forefront and do cutting edge research? I mean, what are some techniques that research will employ to like really make optimum use of the time you have?
Okay, actually this is funny because this is actually one of my biggest problems right now, which is time management. And many years ago, I actually asked Reinhardt this question. How do you do it? And he told me, calculated irresponsibility.
That's a good point. I mean, there are different characters, right? And some of us want to really be perfect. Perfect on all accounts, 100%, no, 105%. I wouldn't advise that. It's really important to pick out the key things you should know them well, go after them, and work hard, and then after a while make an accounting of where you are. And don't stay too long. Again, let's go to Charles Towns, who changed fields several times in his life. And he always, I'm sure Eric, you have experienced that too, would tell you, well, look, it's like going into a new forest and you explore the forest. So go into the forest, be courageous, and go where nobody else had gone. And then you check it out and you understand what's happening in the forest. But once you see other people coming into the forest after you because they've heard you found so many good things, leave the forest.
Well, sort of the question kind of drifted to another one, though. So we can come back to this one, but actually I want to sort of follow up on what Reinhard was saying, because it strikes me now that all three of you actually are opportunity-driven scientists, right? I mean, George was saying that you would just listen to an interesting problem, you didn't think it was interesting until you heard it, and then you thought you could solve it. And there was also saying that you followed the technology because you thought the problem was not your initial science, but you thought interesting questions would come around. And we just heard sort of the same kind of spirit here, that don't stay too long, look for the path that just is not too many steps before you. So is that an advice you would give forward to students that not, because I think many students and postdocs here are afraid of maybe I'm projecting this, that they need to publish papers in what they already know because they are judged by that. And then, where is the balance there to try new things against, showing that you know something very well?
Well, this is a difficult balance. I think that it also depends from character, from the situation. So for example, one point that is very important for scientists is to have enough self-confidence. Self-confidence is very important because if you don't have self-confidence, you do not solve the problems. And however, to build self-confidence is something that is not easy, and you need something, maybe anything that helps with self-confidence may be very important. Okay.
Any comments from the...
I think actually the second question is such an interesting one. I have a visual way of thinking about this in terms of what is our job as scientists? It's to move the frontier of knowledge forward. And it's it's interesting to find the opportunities when you can make transformative changes rather than incremental changes. So I feel like we often go around kicking the boundary of knowledge, trying to figure out where is the opportunity to really move the needle, and what's changed, either technologically or in terms of our understanding from other fields that allows you to make that sort of really, where it's weak at the boundary and you have that opportunity to move forward. So I think there's an interesting balance between taking those risks and knowing when they're working and when they're not. So cutting your losses when they're not working, you gotta try a lot of things that fail, and then really investing when it's really interesting. So it's, I don't know, I think there's some artistry in terms of knowing when to go and knowing when to stop.
Thank you. More questions? Well, again, Axel, come on.
It's somewhat related, actually. In the case of Andrea, you said that your proposal was first rejected because the referees didn't believe that it was possible to observe the stars so accurately. So was that in the end, did this in the end have a positive effect on you in that you actually were able to make better science after that by being more accurate in planning the work? And related to this question then to Reinhard, did you face similar hurdles when you were first proposing and wanting to do these observations? What was the outcome and what was the response?
So at this point in my life, my favorite expression now is every challenge is an opportunity. So in that case, it is absolutely true that it forced us to think through what were the objections, what were the criticisms, and how could we write a better proposal, and also do the advocacy. I mean, you have to realize that that was my first year as being faculty, and it was really important that I understand that I was within a system, the University of California system. So it was one thing to have my local colleagues convinced and excited and either collaborating or enthusiastic about it. But in fact, it required everybody on this committee who was from all sorts of campuses. So the fact that you really have to go out and advocate for your ideas. I mean, the idea that it's not just doing your science, there's a lot of social issues behind doing science. And this is just one of them.
Yeah, I don't know, Andrea, how far you had to go in your proposal description in terms of the projection forward. It's very clear that if either of us or anyone else would have had to argue on the basis of the stars, which are now the key element of the proof, the peer review would have given us a clear-cut negative answer. In my case, we didn't even ask the question. We were privileged on one score that the Max Planck Society indeed is different from other organizations in that they have a basically trust-based system to a considerable extent. And the other side was I, at the time, got a prize, and the Director General of ESA heard about this and felt it might be interesting to start a collaboration. So that got us onto the then otherwise holy grounds of the LaCIA telescopes, which were not allowable to be used for anyone but ESO instruments. Okay, but we didn't have to make the case for did you have to make the case for the S stars already? Well, that's... I understand.
So I think there was a question in the back, yeah.
I don't know if you can hear me very well, I hope so. So the question I wanted to ask is, when you encounter a difficult scientific problem, how do you personally approach it? And let's say you get stuck. What techniques do you use to change your perspective?
Yeah, we can start with you, George, since you tackled so many different problems.
Yes.
The question is, when you get stuck, with a problem, you don't see the solution immediately. What's your technique to sort of work around it and sort of solve it different ways?
Change problem. This is what But I think the other, yes, essentially, because I have many, I mean, as you've seen, I'm working on many problems, and sometimes I change problem. And look, for example, once happened to me something quite very strange, because it was a problem working with a friend of mine in the 80s. I was not able to, we were not able to find a solution. And one moment I was speaking with a friend of mine that 10 years after, he said, look, this problem is very important because this has a lot of application, and one should able to, you should work on it to find a solution. So I said, no. We were at lunchtime, I believe, and I said, no, it clearly that we cannot solve because it's too difficult. And while I was explaining why it was too difficult to be solved, I explained him at the end how to solve it. But you see, I don't know what happened if I had been working in, I don't know how happened that after 10 years I was able to find a solution, and 10 years before not, but sometimes you are stuck and it's better maybe that you, I mean, it's something like pushing things too much, after you cannot move on laterally because there is too much friction. If you go a little back, after some time you find something more interesting.
That's great. But I guess for astronomers, maybe waiting for 10 years to solve the problem, it doesn't work. I guess you have, what's your, for the two astronomers in the room, what is your way to sort of try to come up with a solution where you don't see the solution at once? What's your strategy to solve it?
You move elsewhere.
Yeah, exactly.
I would absolutely agree with Giorgio.
Okay.
There may be dream things you would like to do which are not possible, and you better move elsewhere. Otherwise you get a bloody...
Actually, I really think this point about talking to people, so having colleagues that we can talk to, is a great way to problem solve. And it's one of the things that I worry most about the impact of COVID, is that we've kind of gotten out of the habit of having these conversations around problems that you wouldn't, sign up for a Zoom meeting to discuss, but you might discuss over coffee. I also found that it's really important to find times when I'm disconnected. So for me, over the years, being able to look away from the problem, which I like to do in the swimming pool, because in the swimming pool I can't look at my phone, I can't talk to other people, no one can bother me. And it's a place where you're not necessarily thinking about the problem, but your brain can work away. So finding that quiet, I think is really important.
It sounds like either total solitude,
yes, exactly.
or
social or just isolation.
One of the two, but not anything. Sounds great. Good recipe.
Let me give another example. It means that sometimes, of course, a change problem works in certain cases, but if you are writing a program code, a computer code, the code does not work, it's clear that you have to solve the problem. And also if you are stuck to solve, and what happened to me is sometimes I spend the whole morning to try to solve the problem, to find the error in the code, and sometimes when I drive back home, driving, I get, that line of the code must be wrong. And when I go home, I find the line of the code that it was corrected, that was the type of mistakes. Because in that, when you don't have the code in front, you start to think about which could be the possible mistakes. Instead of trying to find the mistake in the lines, we say, but which kind could be the mistake that gives this strange type of result? And reasoning that way, you find.
It sounds similar to what you explained about you explaining to your friend. You're trying to sort of get the problem to the most basic elements, and then maybe it's easier.
Yes, essentially, yes.
Any other? Yes, Lucia.
If you can hear me, this is also a question for all the three of you. You clearly, each of you have so many responsibilities, right? So did somehow winning the Nobel Prize add a bigger responsibility? And if so, for each of you, what is that? It could be a scientific or a social.
Can you repeat?
Yes. So each one of you have a huge number of responsibilities already, and then you won the Nobel Prize, and then you have even more responsibilities. So how, you know, how does, I guess, how was your workload or responsibility?
No, it was more like, did you feel like it was a bigger responsibility, and if so, what it is? Whether it was more scientific or social?
Yeah, your responsibility as a Nobel laureate. What added responsibility you think you got?
Well, the problem is, I think that when after I got the Nobel Prize, that I became a Nobel laureate, I had many more responsibilities for one unfortunate reason, that most, all other Nobel Prize, Italian Nobel Prize, do not live in Italy. They live outside from Italy. So therefore, I'm not the only Italian Nobel Prize, there are many of them, but they all outside. Therefore, for any type of things that is needed a Nobel Prize, people ask me, and not only, there is the problem that being a Nobel Prize, you may have the chance to discuss with politicians and for things that are connected to the future politics, the future research, the financial research, and the type of renewable energy and so on. Therefore, I have also it's something that was trying to do in the past, but not without so much success. Now everything is much easier, and this is a lot of work that I have to do because. And unfortunately, I'm not the only one. I hope that there will be a new one.
Small message to the committee, you know.
Well, also chemistry and mathematics and medicine will be fine.
We'll work on it. Okay. Everyone's taking notes here.
I think it's a really interesting question. I mean, it's very, it's like science in terms of disruption. It is definitely disruptive to your professional path. And it gives you an opportunity to think about very explicitly what direction do you want to go? Because all of a sudden you have invitations that you wouldn't ordinarily get, both in terms of short-term things to do, but also different kinds of jobs. For me, it made quite clear is that I'm still interested in doing science, and I want to make sure that I preserve enough time to do the science, while at the same time I very much feel the sense of responsibility of being somebody who's in a position to argue, at least within the United States, for these really big telescopes. You know, there were people before me who argued for Keck, and I really feel the sense of responsibility. Plus the added overlay of being the fourth woman to receive the Nobel Prize in Physics, trying to understand how to fulfill that responsibility. I still haven't figured that out yet.
Oh, well. I mean, when the news came, I got immediately various emails from friends and said, well, you are aware you're entering now the most difficult part of your life. Now that actually for 1 year I was spared, we all were spared because of the pandemic and the fact that we now have Zoom. Because that traveling that really can bring you down. And unfortunately this year I've been doing just that. I jokingly say I'm part of the entertainment industry. That's fine, because it gives me the opportunity to talk to young people, and so of course that's all great. I'm doing pretty much the same thing. Where it becomes dangerous is where you talk to politicians. This is where you have to watch out to not overreach.
Yes.
So I have a question about telescopes. Why building two 30 meters telescopes rather than joining the efforts and resources to build a single one?
Well, I'm going to take that one for at least one stab at it. In fact, there are three. So you might ask, why three, not two? Because I can give you an argument for two. So for ground-based telescopes, you'll notice that there are telescopes in the north and telescopes in the south. So to, in fact, see the entire night sky, you need telescopes in the two hemispheres. So in fact, that's why you'll notice that there's one's around 30 degrees latitude and mine is 30. That's the way you get the whole sky coverage. So 2 makes sense. 3 is more complicated. And that comes back to politics and sociology. And yeah, there are sociologists studying the development of these projects.
You can solve that problem too.
Well, look, scientific research, we know in the Enlightenment document, so to speak, it says, thou shalt prove or disprove, and thou shalt see that it can be done no more than once. And the fact that we were at the same problem was great for everyone looking on, because they sat like you, and if we said the same thing, they said, oh, it must be true. If we didn't say the same thing, happened so much before, then they knew, okay, maybe more work needs to be done. So just for scientific truth, and scientific truth does exist, it's not bad to have it twice. We have now 1 or 2 examples on the ground of world telescopes. I would argue they don't work very well, because the cultures can be very different. I mean, the way, say, California runs its telescopes is different from the way Europeans run their telescopes at different aspects. One should, in terms of what you call diversity, accept these to some extent, and not try to, push one culture onto everyone. So in that sense, if one can afford it, having 2 is not that bad. Okay, but primarily because you can check.
Let's see, I have a question there.
Do you have any advice for future PhD students or current PhD students, or maybe some advice that you would give to a younger yourself, or something like that?
And advice to younger yourself. If you're now knowing, what things had you just known when you were at the beginning, young student, the things you know today, what would you have done differently, I guess? What advice would you give to the younger version of yourself?
Follow your passions.
I mean, you want to know what advice you give to young people?
The young version of yourself, I guess, is the question, yeah.
Well, one very difficult to say, because on certain case I was one thing that I was doing as young myself, I was doing too many things together in a certain period. So doing too many things together, the final result that you don't do, or many of the things that you try to do not work well. But on the other hand, I think that doing many things together, this helped me to bring a certain kind of interdisciplinarity. So I'm really puzzled, because I think that as I told you, I was quite lucky and I find that just going some kind of serendipity. They're looking from something. I found something that was not. I found something else. I don't know which advice to do, because maybe if I do some kind of advice that to push too more things in one direction, I could miss some others. So really, I don't know if I could give some advice that would be good or not. I mean, so for example, one advice could be concentrate on energy physics. This certainly would be a good idea for certain viewpoint. Probably would have some success in my first year on high energy physics, but maybe I would lose all the things that come from statistics and mechanics. So, I really don't know which advice to give.
No advice? This was a tough question. Thank you. Nikki?
Sort of following up about doing many things at once, I feel like in academia this requires from you to know a lot of different skills, not just science, programming, but also writing,
presenting, advertising your work, networking. And for me, it's always difficult to feel like, should you really focus on a few things to do well or on everything? And I was wondering how you sort of tackle that in your own career.
You can, in most cases, do everything. It's impossible. That's why, at least in the experimental world, but increasingly so also in the computer science world, collaborations become essential. Teamwork is essential. Of course, how to structure a team in a fair way is not easy. One has to work at it to make everyone happy, and that's the job of the leaders as well as the entire team. But don't try to do everything. That will spread you so thin. We talked about this earlier. That it's likely that you won't get anywhere.
In a job like mine, where you're a professor, there's sort of three big arenas where your career is evaluated. So the research domain, teaching domain, and the service domain. And the plus side of academia is you have incredible freedom within those three domains to figure out what floats your boat. So this advice about follow your passion really applies to all three domains. So in the beginning, I found it interesting and complicated to figure out what I enjoyed and where I could make a difference. So all my teaching now, all my teaching is at the undergrad level because that's where I think I can make the biggest difference. And I feel passionately about it. And when you're passionate, it doesn't feel like work. In the service domain, I've discovered that these big telescopes, there's a lot of service that's required. So rather than trying to do service committees that are disparate, I try to concentrate and think about what is the community problem that I want to invest in. And I consciously evolve as one problem resolves into the other. So there's an art, which I think I had a hard time with in the beginning, which was saying no. I actually had a file where I practiced saying no once a day.
Well, that's right what you say, that being an academic one has a lot of freedom on what to do, especially in my first years, because I was a researcher, I had no teaching responsibilities up to the age of 33, something like that. And I think that one thing that is very important is that you should concentrate on things which makes the difference. This is something that I think that is a very important thing that you stressed, because also when people are young, they should study, going to decide which field they are going to study. Of course, in the first stage, you must learn things and so on, but when you are more adult, when you are more mature, I think that it's important that you concentrate on some subject where you feel that you can make the difference, and this is a very important suggestion.
Great, thank you. I think that was a pretty insightful suggestion. Is there is a question there first? Yeah.
I have a simple question for Andrea and Reinhard. Recently, the Event Horizon Telescope took a picture of the black hole at the center of our galaxy. That's the same thing you were looking at. How do you compare, and what are your opinions about what went on there?
It's fully consistent with what the prior is which we've given them. So the general relativity would tell you that light is bent, and therefore there's a characteristic radius within which the light does not, if it comes from behind the black hole towards you, it won't reach you, okay? So that gives you a characteristic dark shadow region. And that you can compute from the mass and the distance to the object very precisely. And the numbers which we have calculated from the stars is a very precise number. So you have a prior, and that prior is very accurate, and the measurement is exactly what it is. Now, it has to be said, we still hope to see more out of the EHT coming. I mean, Jim, you should maybe talk more about this. I mean, clearly there are time domain effects to be looked at. There is the issue of magnetic field structures which need to be looked at, not only just the pure GR effects. Whether that shadow, or in that or any other black hole, can be used to measure the still not measured spin of a black hole, I'm a little more doubtful.
Okay, I think we all started to look satisfied with all the answers we've received from you three today. I think it's been a wonderful afternoon for all of us. Thank you again for visiting us, and let's see another round of applause for